In our chapter on miscellaneous TLS topics, we have reached the lesson that's dedicated to the question whether within TLS the application data exchanged between the client and the server is protected with non-repudiation or with authenticity only. To understand whether the application data exchanged between the client and the server is protected with non-repudiation or with authenticity only, it will help to briefly recapitulate what the overall objective of TLS is and what the 5 main cryptographic processes taking place within TLS are. The objective of TLS is to construct a secure channel from an insecure channel between a client and a server that have never met before. This secure channel is constructed by authenticating the peers involved in the connection and by having the peers agree on a master secret. From this master secret, symmetric keys are derived for the purpose of symmetrically encrypting and authenticating the application data exchanged later on. So with this, I actually already provided the answer that the application data exchanged with TLS is protected with authenticity only and is not protected with non-repudiation. The symmetric keys used for the protection of the application data are derived from a master secret known to both the client and the server, and as such, the origin of the data could be either with the client or with the server. As such, the application data does not have non-repudiation. Now, to just briefly elaborate on how the symmetric keys derived from the agreed-on master secret are used to provide the application data with authenticity. Within TLS 1.2, the application data exchanged is provided with authenticity by means of either an explicit HMAC calculation or by means of the implicit message authentication part of the authenticated encryption with associated data ciphers, as for example given by the GCM and CCM block cipher modes of operation. Both of these approaches are symmetric approaches, making use of the same key on both the sender and the receiver side. Again, this makes clear that the application data within TLS 1.2 does not have non-repudiation on it. For TLS 1.3, it's essentially the same as within TLS 1.3. All cipher suites use authenticated encryption with associated data ciphers, which are either given by the GCM or CCM block cipher mode of operation or by JA-20 Poly 1305. Again, clearly, these are symmetric approaches, and as such, application data within TLS 1.3 does not have non-repudiation on it. Great, I probably now made it very clear that application data exchanged within TLS is only protected with authenticity, but not non-repudiation. A follow-up question worth to then answer is what the X509 certificates are used for then. Well, the X509 certificates used within a TLS connection are used to authenticate the server and the client. In TLS 1.2, the server authenticates itself in case of an ECDHE key exchange by digitally signing its ECDHE half key with the private digital signature creation key corresponding to the public digital signature verification key contained in the server X509 certificate. In case of an RSA-based key exchange, the server is authenticated as part of the server finish message at the end of the TLS handshake. This server finish message contains an HMAC tag calculated with the master secret, and in order to get the master secret, the server requires its private RSA key. A client, which generally only authenticates on request from the server, authenticates by digitally signing a transcript of the handshake as part of its certificate verify message that the client sends to the server immediately after having sent its client certificate. In TLS 1.3, both the server and the client authenticate by digitally signing a transcript of the handshake with the digital signatures then sent as part of their respective certificate verify messages. This finishes the lesson, and I hope it's now clear as to why application data exchanged within TLS has authenticity only, but not non-repudiation, and that the X509 certificates used in a TLS connection serve the purpose of authenticating the peers involved.